This is a small video designed for you to understand how to solve problems related to normal distribution or Gaussian distribution. So I already have on the window given a problem. The problem says that for a certain type of computers, the length of time between charges of the battery is normally distributed. So the normal distribution is given with a mean of 50 hours. So and a standard deviation of 15 hours. So we have a 50 hours time for the battery that it can survive. Okay, so that is just an average value given to us, and the standard deviation that is given is 15 hours. Okay, so this is the kind of the battery this computer has or this laptop has, and you want to buy this laptop. So you are interested in some finding out some statistics of these this computers. So the first question you ask, that is given over here in the first part, is that you want to own one of these computers and want to know the probability that the length of time will be more than 70 hours, which means that the battery will last for more than 70 hours. So what is the probability of this? You want to find it out. So you already know that this problem follows normal distribution as given over here. And in this normal distribution, we know that the average lifetime of this battery is 70 hours. So this is the average lifetime. Okay, and we know that this average is called the mu. So this mu is 70 hours, and the second value that is given to us is the value of the standard deviation sigma, and this value is given as 15. Okay, so these two statistics are already given to us, and based on these two statistics we can plot this distribution. So we have this plot already drawn for us with the center, the peak value at the average 70. Okay, so now you want to I'm sorry, the average is not 70, the average is 50. So let me just correct it. This is 50. Okay, so the probability that you want to find out in the first part is that this computer, that if you buy one, what is the probability that it will have more than 70 hours of battery life? So 70 will be somewhere on the right of this figure 50. So somewhere over here, let's just point out this value. So suppose this is the point for the value 70. Then you want to find out this probability, the probability after this point, okay, in this direction. So note that you are interested in this area over here that I've highlighted in yellow. So this is the probability that you want to find out. So as we discussed in the previous lecture when we were discussing the characteristics of a normal distribution, we said that usually when we are trying to find the probability in a continuous random variable, what we do is that we integrate the PDF. So for normal distribution, since that integration is not very simple and convenient, what we have with us is the Z table or the Q table. The both tables are available to us, and these tables provide us the probabilities of different chunks in this plot. So we take help of these tables, the Z table or the Q table, to find out this probability range, for example, given to us in this problem. Okay. But the first thing that we discussed in the lecture was that before we find out this probability, let's call the x-axis as small x. Okay, so the random variable is x, and before we solve this problem with the help of Q table or the Z table, what we need to do is we need to transform this normal random variable into a standard normal random variable. Okay, and the difference is that in a standard normal random variable, the mean is 0, and the variance or the standard deviation sigma should be 1. So once we apply this transform, the shape of the normal distribution of course remains the same. It still looks like a bell. However, the variance or the standard deviation changes from 15 to 1, and the mean changes from 50 to 0. So we already know that the mean has moved from 50 to this value 0. The next question is, where does 70 move? 70 will still be somewhere over here. Okay, but we do not know the exact value of 70. So I'll find out this value and I call this value Z. So to find out this value Z, I use this equation as we discussed in that lecture to find out this new value of Z. So as per this equation, the value of Z comes out to be 70, since the value of x is 70 over here. 70 minus 50 divided by 15. Okay, which is 20 by 15, or simply 4 by 3. Okay, or something you can say this is almost 1.3, so we will stick to 1.3. Okay, so the value of z is 1.3. Okay, so we know that this point is actually 1.3, so that is what we know now. So what do? Now we try to find the probabilities after this point 1.3. Okay, so this is the area that we want to integrate, or using the table, this is the area that we want to find the probability of. Okay, so we will now look into the table, and the table will tell us this probability. Now in this example, I'm going to use the Q table. So you can also use Z table, and I would recommend that you solve this problem again with the help of Z table, so that you can understand both of these tables well, so that if in future if you require to work with only with one of those, you might be able to solve the problem with any of these tables. Okay, so I'm going to solve this problem with a Q table. So the value of Z is 1.3. So what I'm trying to do over here is find the probability that the laptop has a battery of more than 70 hours, which is equal to the probability that the value of Z is greater than 1.3, because I made this transformation. And to find out this probability, I'm going to use the Q table, and the Q of 1.3 will actually tell me this answer. So why Q of 1.3 will tell me this answer? Because if I remember from our previous discussions, the Q table tells the probabilities from a point onwards. So if I put the value of 1.3 in the Q table, it will tell me the probabilities after that point. So if I put the value of 1.3 in the table, it will tell me the probability after 1.3. Okay, so I'll just look into the table now, so that I can find out this probability. So I have this table over here. So these are the values, and these are the probabilities after that point. So I'm just looking for 1.3. So this is the value of 1.3, and after 1.3, the probabilities that remain towards the right, they are equal to 0.0968. Okay, so 0.0968 should be the answer. 0.0968, or you can say 9.6% is the probability or the chance. 9.6% is the chance that you will have the battery will last for more than 70 hours. And again, we made this transformation before we solved this problem for normal random variable to standard normal random variable. Okay, if we did not make this transformation, then how would I have been able to find out these probabilities using this table? Because if you notice, this table has very small values, so from 0 up till 9. So even the 9 is a very large value. Usually this table is plotted for values roughly 3 to 4 to 5, and that's it. Because after those values, if you notice, the probability falls sharply to the very small values near to 0. Like look at this value at x equal to 5, let's say. So at this point, at x is equal to 5, the probabilities after the point 5 are actually very small. So this is something 10 raised to a minus 7. So these are very small values and very insignificant values. So usually the tables are not plotted for such values. So usually smaller tables can help to solve our problems as well. Okay. So for this value, the answer came out to be 0.0968, which is 9.6%, and already a very small value. Okay, even though we are just 1.3 steps away from the center. So 1.3 times the standard deviation steps away from the center. This is our current position, and the probability comes out to be this much. In the part 2, if you notice, it asks you that you want to know the probability that battery will last less than 40 hours. So what it is asking now is the probability that the battery will last less than 40 hours. So 40 will be somewhere over here, and it wants to find the probability in this range. Okay, less than 40. So how do we find this probability? Again, the first thing that we do is the transformation. So we transform 40. So instead of the value 70, now we put the value of 40 in this x. So the answer that we get is 40 minus 50 divided by 15, which comes out to be minus 10 by 15, which comes out to be minus 0. I think it is close to 0.7. So I'll just stick with 0.7. Or let me just confirm with the calculator. So let's just write the exact value because obviously 7.7 is not the exact value. So this value comes out to be 0.66, not exactly 7. So this value comes out to be minus 0.66. Okay, so this is the value now. So now we know that this value 40 maps to the value of minus 0.66 in this plot. Okay, or let's just use this new plot over here. Minus 0.66 lies somewhere over here, and we want to find out this probability, okay, this region less than 0.06. So this is what we are trying to do now. For part number 2, what we are trying to do is find the probability that the life of the battery is less than 40 hours, which is equal to the probability that Z has a value less than minus 0.66, okay, which is equal to, now we want to find out this probability. Now if you notice, the Q table does not have any value that is negative. So it starts from 0 and goes towards 9. So how do we deal with the negative value? Okay, so this is the problem that we are stuck with. So the answer is that if you look at this plot of this normal distribution, we know that this normal distribution has a symmetric shape. Okay, so this shape has some symmetry in it. So if you look at the origin, then from the origin, the right side and the left side look the same. Okay, they are symmetric across this point of x is equal to 0. Okay, or you can say that the this plot is reflected across the y-axis. Okay, so the right and the left side looks the same. The graph is symmetric. So if you want to find the probability after this value x, this much probabilities, these probabilities will be same as the probabilities before this point minus x, because the plot is symmetric and the area under this curve is the same as area under this curve. Okay, so we know that since this thing works, then the table does not need to include the negative values. We can only work with the positive values because these same values will provide us the probabilities for the negative regions as well. Okay, so having known this property of normal distribution, so what we do now is that we are going to find the probability before this point, the minus 0.66. Okay, and now we know that the probabilities that this region of before minus 0.066 is the same as the probability that the region encloses after 0.66. Okay, this much. So these two probabilities are same. So since I want to find out the probability that Z is less than 0.66, I know that this probability must be same as if Z is greater than 0.66. Okay, so this is a negative value, this is a positive value. So the positive values are given in the Q table, and in the Q table, if I put Q of 0.66, it will tell me the probabilities after this point 0.66, and this is what I need to answer. So this is what the answer is. So I just have to look into the Q table and find the probabilities after this point 0.66. Okay, so let's just look at the table. So here is 0.65. Now this value is not exactly 0.66 because this table is presented in denominations of 0.05s. So the increment is of 0.05. So after 0.60 we have a value of 0.65. So this value is close enough and we can work with this value. So there's no problem. And the answer that we get is 0.257. Okay, so that is roughly the answer, 0.257. So this value must be 0.257. So this is the probability, or roughly you can say that there's a 25.7% chance that your laptop will last for less than 40 hours. So this is what we know now. Okay. Okay, apologies for this. So let's look at the last problem now. The last problem says that the part number 3, that you want to know the probability that the battery will last between 40 to 70 hours. Okay, so for 40 to 70 hours, this is the new problem for us. So this is the probability that we want to answer now. The probability that it lasts between 40 and 70. Okay, so this is the answer that we need to give now. So if you remember from our discussion, this is a continuous random variable, and equality or inequality does not matter. So either you write equal or you do not write equal would not affect the answer. Okay, so this is the probability that we need to find out. So again, I have already transformed these 2 points. 70 transformed to 1.3. So 70 would transform to this point 1.3, and 40 will transform to minus 0.66, which is over here. Okay, so I need to find the probability in this range. So this is the range that I'm interested in calculating. So this red highlighted area is the probabilities that I need to find. Now if we have looked into the Q table before, and we know that the Q table does not give us the probability of a certain region. In fact, it gives the probability from one point all up till infinity. So I cannot stop somewhere at 1.3. So how do I deal with this problem now? So the way I deal with this problem is that first I try to find out the probability after this point, minus 0.66. So I want to find out the probability after this point, towards the right of this point. So how much probability is there? So the probability after minus 0.66, if you remember, is the same as the probability before 0.66. Okay, because of the symmetry. So after 0.66, I have the same probabilities as before 0. After minus 0.66, I have the same probabilities as before 0.66 due to the symmetry. So what is the probabilities before 0.66? So I have already found the probability after 0.66, which came out to be 0.257. So if this is the probability after 0.66, the probability before 0.66, they must be 1 minus 0.257. So they must be 1 minus 0.257, which is actually equal to 0.743, I think. Okay, so this is the probability of this region, and obviously it is quite high, because 50% of the probabilities are on the right of the mean and 50% probabilities are at the left of the mean. So I'm considering not only the whole right side of the mean, but some values over here as well. So that value is more than 0.5, and it is 0.743. Okay, so this is the probabilities that I have got of the region after or at the right side of the minus 0.66. So I've got this value. So now what I do is that I find the probability after 1.3. Okay, so the probability after 1.3, so this much probability after 1.3 is already given in our problem, that is Q of 1.3. So this probability came out to be 0.0968. So the probability of this region is 0.0968. Okay, so what do I do with these two values? So now if you notice, the 0.0968 is the probability of this region. Okay, and the 0.743 is the probability of this whole region from 0.66 and onwards up till infinity. Okay, so if I subtract these two values, that is, if I subtract this larger portion, I subtract this smaller portion from this larger portion, I would be left with these values in the middle over here in this interval, and this interval is the probability that I actually needed to find out. Okay, so from the larger area I subtract the smaller area. So what I do is from this larger area or this larger probability, I subtract the smaller probability, that is 0.0968, to get the answer for this interval in between. Okay, and by using this calculator, I'm sure you can find out this probability rather easily. So let's just find it out. So 0.743 minus 0.0968, and the answer comes out to be 0.642, or roughly you can say 64.2% chance that the battery will last between 40 and 70 hours. So by solving this one problem, I'm sure you will be able to solve all other problems, because in other problems all you will need to do is to find out the mean of that problem in that random phenomena that is normally distributed, check what the variance is, and using this transformation then transform that normal random variable first into a standard normal random variable, and then find out the different ranges of probability that you need to find out. And using the Q table as given over here, or by using the Z table, you can then find out the probabilities of all kinds of regions. So I hope this problem, the solution of this problem helps you, and you can solve the other problems as well via the same method. So I suggest that you solve this problem again with the help of a Z table.